So come with me to the whiteboard and let's continue with our lessons. So what are we talking about today? We are still on the major topic, algebra. And we are looking at one important operation in algebra, substitution. Substitution is a very important skill we need to master in algebra if we are to go on and solve more complex algebraic problems. Now, as the name suggests, substitution, we are putting something in place of another. So, for instance, when you go to a football game or you are a football player and you have played and you are tired, the coach can see you are tired and he can substitute you. When he's substituting, what is he doing? He's recalling one player off the field and replacing the place of that player with another player. Okay, it depends on what the coach's strategy is, but substitution is something that we do in life. In algebra, we also use substitution to help us to get a clearer picture of what an expression stands for. So what then is substitution in algebra? Replacing a variable with a known number. Okay, so you can have a very simple expression. L is equal to m plus 5. You see this expression, it leaves a lot for us to find out. There is L. We don't really know what L is, how big or how small L is. Then there is M. We don't know much about M. Of course, we know 5. If we are trying to see how big or small something is, when we say 5, we can understand how big or small that thing is, depending on the context. Now, with substitution, we can get a clearer picture of what L is. Okay? When we go on to find more information about M, let's say M is equal to 4, then we can bring this 4 into this original statement, and that can give us more information about L. And doing so, replacing M, which is unknown, with a known quantity, which is 4, that is what we call substitution in algebra. So let's look at an example. You could get a question like this. Find the value of L given that M is equal to 25 in the following expression or in the following equation. L is equal to M minus 14. Okay, so this is a very simple question I've made up to illustrate what we do when we are doing substitution in algebra. So we want to have more information about L. Perhaps we are trying to figure out how big or how small L is. Okay, but in the expression given for L, or in the equation given for L, M is standing in the way. M is not helping us appreciate how big or small L is. We are struggling to get a true picture of L. But looking into the question, they've given us some more information about m. They've told us that m is actually 25. So we can substitute this m, we can replace this m with 25. And once we do that, we can actually go on and solve and find the real value of L. Okay, once we know the real value of L, we get a better picture of L. So looking at this, we can say that L is therefore equal to m. In place of m, we can put 25. We can substitute m with 25 because we've been given that m is 25. And then we will carry on with the rest of the equation, which is minus 14. So L then becomes 25 minus 14, which is 11. So now we know the value of L. Okay. It's very simple. Let's try one more example. Let's try one more example. Ben must work 3 hours to be paid £75. Ben must work 3 hours to be paid £75. The formula for his wage is Let's look at some simple questions that we can use substitution to solve. The first one. Find the value of the expression given that L is equal to 50 and M is equal to 4. Okay, so this is a very simple question again for us to practice how we can work substitution. And don't just get bored yet because you find this so easy. I'm just building up to a point. So here, we want to know the value of this expression, but it is littered with variables. We don't know what L is. We don't know what 2M is. For us to be able to know the real value of this expression, we first have to know the specific values for all the variables in them. So when we come a step further, the value of L has been given as 50 and the value of M has been given as 4. So we go on and we try and substitute. So what do? In place of L, we are substituting it with 50. In place of M, we are substituting it with 4. And mind you, this is a product, okay? So just a bit of a revision. This 2 then becomes a coefficient of the variable M. If you remember from our previous lesson, what a coefficient is. So we are multiplying, and then M is 4. So 4. And then Again, let's recall on our previous lesson. We should apply BODMAS to solve this correctly. Some students can go and add this bit first to get 52 and multiply that by 4. If you do that, you are going to get 208. But that will not be correct because you have not carried out the multiple operations in the right order using the acronym BODMAS. Okay, so you have to do it in the correct order. So 50 plus 2 times m. This is what is going to give us the value of that. With BODMAS, we need to substitute m with 4. We've done that already. According to BODMAS, we first have to do this first. In BODMAS, multiplication comes before addition. So we need to do that one first, 8, and then we add it to the 50 and we get 58. So find the value of the expression L plus 2m, given that L is 50 and m is 4, and the value is 58. Okay. And I was deliberate about bringing this BODMAS. If you have not checked our video on BODMAS, please look for it in the playlist and go through it. Many students do the correct thing until they come to some of the very basics of maths, and then they misapply the principles and they are not able to score the full mark. So as I told you, in this channel, we are working our way upward from the basis. We have looked at BODMAS because BODMAS becomes useful when you are doing algebra. And here, clearly, a student who has not paid attention to BODMAS will get an answer 208, and that will not be correct. A student who is applying the principles of number, where we looked at BODMAS, to solve this algebra question correctly will get 58 and will score the full mark. So that is what we need to do. Now let's go on to something. I want to introduce something that is very helpful in substitution. I know we have started simple. I intentionally started with a very simple problem that anyone can do. But it can get complicated. It can get complicated. It can get complicated with negative numbers and powers. Okay, sometimes even roots. Okay, now when we are doing substitution, this is where we are going to crank up the difficulty a bit. When we are doing substitution, sometimes we get so many expressions, and if we don't group them, we can get lost in the clutter. So in algebra, when we are doing substitution, there is a very useful component that is helpful, and that is brackets. Okay, we are free to introduce brackets to help us to separate the clutter when we are trying to solve an algebra problem based on substitution, so that we can do everything in the correct order, step by step. So you are always free to introduce brackets into your expression when you are solving an algebra problem based on substitution, and that is what we are going to do next. So let's look at an example. Let's look at an example. So let's look at an example where it will be necessary to use brackets to help us to work this correctly. So there is a question on the whiteboard. Find the value of 3s squared minus 5 when s is a, 3, and b, -4. So there are two parts to the question, and we have to solve each one individually. So let's start with the first one. The first one kind of has a positive substitution, so we really can do without brackets. So let's go on and solve the A part. A, 3s squared minus 5. So all what we need to do, we are told that we should find the value when s is 3. So we need to look out for this s, and in place of the s, we can substitute with 3. So it then becomes 3 times, remember, coefficient of s, so 3 times s squared. S is 3, so 3 squared minus 5. And then here we will use the principle of BODMAS to solve this multiple operation problem. So first we do the square. Okay, BODMAS, the O comes before the multiplication, so the order. So 9 times 3 and then minus 5. Now we do the multiplication first. So 3 9, 27 minus 5. And the answer becomes 22. So that is the correct answer. How about when s is negative 4? This is where we encourage students to introduce brackets to help sort out the various parts of the expression so that we don't get it mixed up, because working with negative numbers can be confusing. So let's look at a student who decide not to go with brackets and try his luck to solve it anyhow. We have the expression 3s squared minus 5. So one student will just come and do this. 3 times minus 4 squared. We have substituted the s with minus 4 as the question demands, and we are going on to solve this. Now, look at what can happen here. Strictly speaking, when you have a power, the power applies to the number independently from this symbol, because strictly speaking, because we have not introduced a bracket, what we have here is minus 1 times 4. That is what it means. In maths, when a coefficient is 1, we don't write it, but having negative 4 without any bracket telling us that the negative 4 is actually a specific value, as has been advised in the question, what we end up doing is an expression like this. Okay, and because we have failed to introduce the bracket, we are going the wrong way. So what is going to happen, therefore, is that the 4 squared becomes 16 times negative 1 and then times 3. So before the minus 5. What happens is that we are going to get 3 times negative 16 minus 5. 3 times negative 16. Let me quickly do this. Minus 48 minus 5. And here we are getting minus 53. But that is not the correct answer to this problem. Let's look at what a correct solution is, and a different solution in that regard when we simply introduce brackets. So 3s squared minus 5. We are finding the value of this when s is equal to negative 4. So a safe way to solve this is 3, bring your brackets, negative 4 squared, because that is actually what it is. Now, in the place of s, we have negative 4 and then minus 5. Now, what happens here is this. We are squaring the whole of the negative together because the square is now sitting outside the bracket. Compared to this part where the square was not sitting outside the bracket and therefore was only impacting the 4, and that was a separate quantity too, -1. Although in maths, when a coefficient is 1, we don't write it. So introducing the bracket, it helps us to separate them and put the substitution in their correct place. And we don't mix anything up. So this gives us 16 times 3, which is 48 minus 5. And so 48 minus 5 then becomes 43. And this is a correct answer. Okay, let's go on to check another. Let's go on to check another question. I have another question here where even introducing a bracket becomes even more important, because this time we are not only dealing with negatives, we are also dealing with squares. So a correct solution will be to introduce brackets in this expression. Find the value of L equals a squared minus 8b squared. So L is equal to a square. I'm introducing a bracket and put the minus 6 in a bracket minus 8. And then because b is positive, I may or may not use a bracket. It really wouldn't matter. It really wouldn't cause so much confusion. But we can again follow best practice and introduce a bracket and put our square in it. So what therefore happens is -6 squared becomes positive 36. Now, what would have happened if we didn't introduce a bracket? If we didn't introduce a bracket, we would have gotten an expression like this. L equals minus 6 squared. But technically speaking, this now becomes -1 times 6 squared. And that leaves us with -36. And that will not be correct for this substitution. So to keep it safe, whenever you are handling negative numbers or powers or roots, introduce your substitution in a bracket. The bracket protects you from mixing it up with the rest of the expression. Solve what is in the bracket and then go on to simplify your expression to get the correct value. So here, 36 minus, again here, this becomes 4 times -8, which is minus 32. And then we can now solve this by 36 minus 32 is 4. So that becomes the correct answer. We will look at one more example where we are actually applying the principle of substitution to solve an everyday problem. So that will be the next example that we will look. Then we bring this topic to an end. Thank you. We are coming to an end of this topic, substitution. But before we do so, I want us to look at an example of a question that we could have in an exam where we can use our skill in substitution to solve it entirely. I want us to take the information from the question. So I'll read it and then you listen and then process the question also as I read along. The formula for the electricity bill in a household for every quarter is £7.50 plus £0.07 times number of units used. A family used 6,720 units in a quarter. Now the question, how much is their total bill for the quarter? And secondly, the family pays by direct debit of £120 per month. Will they be in debit or credit after the quarter, and by how much? So first of all, let me just clarify certain terms. I recognize the fact that many of you watching may not be in the UK, so you may not understand certain terms. But what is direct debit? Direct debit is just a method of paying bills or paying anything in installments regularly. So for instance, you can decide to pay your electricity bill by direct debit, where you pay £100 every month. So the direct debit system connects to your bank account, and every month £100 go. Okay, so the electricity company will work out how much electricity you have used. If it is more, you will be in debit. If it is less than the £100 direct debit you are paying every month, you will be in credit. So that is simply just to clarify that. Secondly, we are not accountants, but let's look at certain things. If you are in debit, it means you owe the service company. If you are in credit, it means you have paid more than you have consumed, and so you have a bit of money, and the service provider can actually return the money back to your bank account. So these are the things that we need to clarify. Now let's look at the question. A question like this, we can use algebra and specifically substitution to solve. So first of all, let's write the formula for the bill. The formula for the bill is 7.50 plus 0.07 times number of units. Okay, I like to leave the symbols out to keep it simple, but finally, when we finish working everything, we always have to remember to bring the unit if there is a unit, okay, especially in maths, physics, and chemistry. When you work out any calculation, bear in mind that if it started with a unit, or the question is looking for a specific quantity or unit, you always bring the unit. So here the unit is pound sterling, but we will bring the pound sterling when we have had the final answer, so that we don't just interfere the figures with the pound symbol. So how much is their total bill? It's simple. We are going to do substitution. The number of units is a variable, okay? Every family will use different units depending on their lifestyle. This family use 6, 7, 20. So we are going to substitute the number of units with 6, 7, 20. And that will help us to figure out exactly how much electricity they have used. Okay, so it's going to be £7.50 plus 0.07 times 6720. Okay, and for, as I said earlier on in the lesson, we can always use a bracket to make sure that we are segmenting the parts of the expression correctly so that we don't confuse them. So what I need to do is to multiply this number by that. So those of you watching, use your calculators to find out what you get for me. Okay. This one, when we work it all out, it will come up to 477.9. 477.9. Okay, as simple as that. And don't forget your pound sterling unit. Okay, because it is asking how much total is the total bill. So we substitute the 6720 units here, do the arithmetic, and we end up with 477.9. Sorry, 477.90. So that becomes the bill for the quarter. Okay, the bill for the quarter. Now let's go on to the second part of the question. It says that the family pays by direct debit 120 per month. So a quarter is made up of 3 months. Okay, the whole year has 12 months. Half yearly is 6 months. Quarter yearly is 3 months. So when something is presented in quarters, it simply means it covers a period of 3 months. So 120 pounds times 3, that becomes 360. So for over the 3 month period, the family would have contributed 360 pounds, but the bill came to 477. So it means they remain in debt. Okay, so the actual amount that is outstanding becomes 477.90 minus 360. So here we get 0.90 and here we get 711. Okay, so the family actually still have an amount of 117.90 pounds to pay. What is the point of this question? We have used the skill of substitution to substitute the number of units the family consumed into the formula that the electricity company has given. And by so doing, we are able to work out the specific amount of electricity that the family had used over the 3-month period. And that is the application of substitution. We need to master this skill so that when we go on to more challenging questions, we are able to substitute where it makes the question easier to solve, and then we are ultimately able to solve a question. So this brings us to the end of the first skill in algebra, which is substitution. We'll be going on to the next skill. The next skill is expansion. And I'll see you on the other side, and then we will work our way through expansion. Thank you.